Hello everyone, I'm Douglas and I'm going to show you how easy it is to use the Volarious Tethered System for recording and analyzing the traffic footage. So let's begin by going through the four key sections. First, we'll talk about the planning for the shoot. Secondly, we'll look at the things to bring. Thirdly, we will learn about the necessary configuration for the drone camera. And lastly, we will look at how to set up the V-Line Tethered System for recording the traffic footage. Before going to the traffic site to record the footage, we will need to do some planning to determine the process we will take for the traffic shoot. This reduces the risk of needing to repeat or redo the operation due to unsatisfactory result. The key areas of focus are identifying location, weather forecast, and the total time duration of recording the traffic footage. For identifying the location, we will need to look at the traffic site on the Google Map and plan the distance to verify if the field of view can be covered. We also need to make sure the drone is as close to the traffic site as possible, and we recommend between 15 to 30 meters, as it will be the most optimal. Also, to ensure that there's enough space, set up the V-line without much trees that cause obstruction so that the drone can take off smoothly. Moving to the weather forecast, before embarking on any recording or traffic footage, we need to take note that the weather is favorable and that there is no lightning warning. Lastly, with regards to the time duration of the recording, if it is less than 6 hours, we can consider to bring fresh set of fully charged TB47S batteries to hot swap during operation. If the operation lasts beyond 6 hours, you may consider bringing an AC generator. Also, for additional information, 1 hour of HD footage will require 43 GB of memory, so please bring along micro SD card with sufficient memory. We will look at it later in the list of items to bring. When we fly the drones, keep the drone to be approximately 50 meters above the traffic site to be analyzed. At 50 meters, you will be able to sufficiently capture the field of view, and it will be safely within the 60-meter cable length of V-Line Tethered Station. This is a 3D diagram showing the field of view when the camera angle is at negative 90 degrees. But whenever we are using a tethered system, we are definitely going to shoot the traffic at that angle, and hence we will need to take the footage from a distance. This is a 2D diagram that shows the field of view when camera angle is at negative 45 degrees. In such a scenario, do not stand too far off the traffic site so as to optimize the field of view. The recommended variable distance should be from 15 to 30 meters. The steps to take for identifying the location will be first, identifying the location of the traffic site on the Google Map, and then subsequently plot out the distance and measure the area of the traffic site. The area of the traffic site captured is very important. It must be within the range of the field of view of the drone, as shown in the above slides, of width dimension of 75 meters and height dimension of 140 meters. We have divided the list of items to bring into essential and optional. Do ensure that all necessary equipments are fully charged before going on operation. The essentials are Mavic drone with RC smart controller, portable charger with Type-C cable, V-Line tethered station with V-Line power module, 6 quantities of TB47S batteries, and micro SD card. Avoid using the RC standard controller, and we recommend using the RC smart controller instead because you will be able to charge concurrently with the portable charger when you're doing long operation that extends beyond the battery life of approximately 2 to 2.5 hours. For our operation, we use the SanDisk Extreme Plus 128GB V30U3 micro SD, and we will recommend you to give it a try. The list of optional items are AC generator with V-Line AC power adapter, one quantity of Android phone, and a lightning detector. The Android phone is used to run the V-Line application, connected via Bluetooth to the V-Line Tethered Station inbuilt display, which shows key parameters like cable length being read out, total tension applied, and the total battery life left. There are certain configurations we need to take in order to get the traffic footage that is detailed enough for analytics processing. We will look at the field of view, the video resolution, and checking the footage consistently. The max camera angle should not go beyond 45 degrees because much of the details may not be clear or captured. Use at least a HD or even better 4K with at least 24 frames per second. The important thing to note here is that the details for the traffic sight should be clearly seen. Lastly, during the shoot, always check to ensure video is recorded throughout to prevent any possible hiccups. This is an example of comparison between a good angle and a bad angle. So as you can see from the good angle, the cars can be clearly seen from the photo, and it is a top-down view. Finally, we will show you how easy and quickly it is to set up the V-Line for traffic analytics.
So what we have today is a standalone Mavic 2 Pro that we will use together with our V-Line Tethered System. So in my hand, I have the drone. What I'm going to do next is to connect the drone together with the V-Line box. So I'm going to place the drone down, and I'm going to go through the standardized operating procedure on how to successfully connect the drone to the box. So we will basically go through this startup procedure. First, we need to ensure that the backup power module is inserted onto the drone. You notice that this backup power module is slightly different from your standard Mavic 2 battery. So the drone battery is connected onto the drone. Step 1 done. Step 2, inside the V-Line, we have 6 of this TB47 or 48 battery for the Matrix 600. All these are standalone individual battery to use in one set together with this V-Line. So all 6, let me just double check the power level is full charge and ready to go. Step 2 done. Step 3, I will need to connect the cable of the V-Line to the drone. So underneath the drone, we have attached a 3D printed component. This is for us to hook on a carabiner to ensure that there are sufficient slack for this limo connector to be attached on to the backup battery on board the drone. So this will cover step 3 and step 4. Right, step 5, turn on all 6, the TB47 or 48. So I'll make sure that all are powered on properly. I'll do one last check to make sure that all are synchronized. And this will cover step 5. Step 6, I'll proceed to turn on the reel system. So the button, the power on button is over here, one for the reel, one for the tethered power. So now I'll on the green color, which is the reel system. So as I on this system, what happens on the drone is that this hook and the reel, the tensioning system will come online. So observe when I pull up and when I release, the system will auto tension for me and pull back any excess cable. So this is very important during flight. When the drone goes higher or drift away, it will always pull back any excess cable. And this is step number 6. Step 7, I will use a standardized Mavic 2 controller. For today's demonstration purpose, I will actually use together with this Crystal Sky for better screen. So on both the controller and the Crystal Sky to make sure that I access the system. You might not be able to see the screen because the sun is quite glaring, but it's okay. I just want to ensure that I'm able to access the system, and that's it. Right, so this is good. Next step, okay, following step number 8, I will turn on the power module, which is this backup battery on top of the drone. So this is to ensure that the backup battery will be online, just in case anything happens to the V-Line set. The backup battery on the drone will kick in, okay, to supply emergency voltage. So this, okay, I will power on the backup battery, and you can observe that the fan starts spinning, the drone comes online. Okay, and so it's also good practice to unfold all the propeller before you fly. Now, here comes the final step, which is turn on the tethered power switch. So the last step, okay, when you on this tethered power switch, and on it, okay, all 6 of these TB4748 batteries will synchronize with each other and supply, okay, a steady rate of current through the connector into the drone. So that means they will bypass the onboard battery, and now all the power comes slowly from the box. So how do we monitor that the correct current is flowing through? There's actually a screen on the front, and I'm supposed to monitor the standard flow rate that's going into the drone, which is there about 400 volts. Okay, and through this monitoring system, whenever you operate the tethered set, okay, as you go higher, this system will also be able to tell you how much cable reel is being pulled out. So let's say your drone is at 20 meters of height. So the cable out, okay, more or less you give a slightly more. So what I can observe over here on this screen will be there about 20 or 21 meters. So we will monitor all the operational parameters to this screen. And to make it more safe, okay, we also including a system whereby you can use a Bluetooth system, okay, to bring this screen, okay, this monitoring system out onto another phone, where you can also monitor the same setting on the drone from the phone. Then that's where you don't have to stand beside the box. You can stand from a further distance to ensure that all systems are operational. So that will conclude the setup procedure, and we are ready to fly.
Next up, we will have GoodVision talk about how to use their analytics platform.
Hi, I'm Chris from GoodVision, and I'm going to show you how you can use the Volarious system in conjunction with the GoodVision platform. So it's really simple on how to get your footage from the Volarious system. You'll be provided with the footage, and then what you will do is log into the GoodVision system. And you will be presented with a folder which is in the background here blank, and I've created these 3 cameras. To create a new camera, you just click new, you name the camera according to what the footage is or whatever you're choosing. We click save, and it creates a camera for you. Now, this is where the Volarious have provided you with the data from the system, with the footage. You will take that footage and you will upload it into the GoodVision platform. That's done by simply selecting where the file is saved. So if that's in your PC drive, external drive, you will click that, or you might want to upload it to the GoodVision Vault, which stores your raw video footage on our cloud AWS servers. Once you select the video that you want, we take that footage and we'll upload it to the camera. So I have the footage in my GoodVision vault. It's saved in one of my folders here, and this is the footage that has been collected by the Volarious platform. And then I'm going to select the videos that I want. I want these 3. I click process, and I select the camera that I've created, which is camera 2. Next, I make sure the date and time is correct, that it's in line with the recording. Click next, select the drone, processing, next, and process. So now the system will push the recorded data from the recordings from Volarious, and it will go into my camera 2 and take 1 to 2 hours to be processed. Once it's processed, we will be presented with a scene which you can see all different trajectories on. And I want to make a movement for this footage, and very simple. I just take my line tool and I use my mouse and I make a line. I'm going to call this the east movement. So click save. And all I'm going to do is click the new to movement, which is here on the movement tab, and draw a line from south to east. Click save. Brings up some parameters here for me that I can change. I can also reverse the movement, and I can also include the distance from the south to the east line, which I know is 20 meters. Click save. This, by adding the meters, it's going to give you the speeds of each object that is in that movement. It's created it here. I click save. I activate the movement, and you'll see on the screen it's showing you all the trajectories that have gone from south to east over these lines. I can also change the lines at any time and reduce them in size if I just want to look at a single lane. So filter out the other lane and only show me the lane that's on the left side here, going to the east, so south to east. Every movement that I create is created and logged here on your movements tab. And it also gives you the ability to drill down into every movement, these metrics that you see here, from total volumes to gap times to object distribution, and also gather the visual maps here. You can also change the dates and times of the footage that you want to look at. So you might have 4 to 5 days worth of footage, but you only want a single hour on a certain day, which is possible. And once you select the option or the metric that you want, you can then select other sub categories of how it's displayed, so pie graph. Click save, and that will be created on your analyzed data screen, which is presented to you here. I can see from south to east, I have 203 vehicles. I have 128 cars, 13 motorbikes, which it says there's 6.4% of attendance. And I have trucks here, 16.26% attendance. And I have one bus, which is 0.49% attendance. Anytime I can edit these widgets as I wish to remove different classes. I can click next, save, and the widget will be recalculated. Now I can keep going back and forth into my describe scene and making as many movements as I wish with simply clicking the new button, and build up a very in-depth granular picture here. At any time you can toggle as well off and on the categories, so you can see what is included in each of the movements. It's as simple as that. This is how you create a simple movement and upload your footage into GoodVision and start playing and analyzing your data within 1 to 2 hours. Thank you for listening.